All right, welcome back. In this problem, we're going to find the area of the unshaded region. The picture we have contains a rectangle, which is 16 by 18, and then we have two circles that are inside the rectangle that are tangent to the rectangle, meaning they touch at one point, and they're also tangent to each other. They touch at one point right down here. So what we're going to do is we're going to find the area of the unshaded region. If you want to solve this on your own, please pause the video, because I'm going to solve this in just a few seconds. Okay, let's go. So for the area of the unshaded region type of problems, what I like to do is I like to find the area of the large figure, in this case a rectangle, and then subtract away the combined area of the smaller figures. So in this case, it's going to be the area of the rectangle minus the area of the circles. So this is the game plan right here. So we're going to do the area of the rectangle first. Pretty straightforward. That's going to be 16 times 18, which is going to be 288 units squared. Now what we need to do is find the area of the two circles. So the area of the larger circle, I think, is pretty straightforward. The circle goes from the top of the rectangle to the bottom of the rectangle. So this 16 ends up being the diameter of the large circle. So the diameter is 16, the radius is going to be 8. Okay, and the area of the large circle is going to be pi r squared, pi times 8 squared. And we're going to keep it as pi exact for simplicity. So that's the area of the large circle. Now what we need to do is find the radius and area of the smaller circle. And that's where most of our work is going to come in. So I'm going to draw a radius in here on the blue circle. Okay, now we know that this radius is 8. I'm also able to draw another radius over here, also 8. And if that's 8, and the rules of tangency means that meets at 90, this meets at 90, and this is a rectangle, so that's 90. So this is going to be 90 here. So we know that this top is 8, and this bottom here has to also be 8 from here to here. That's also going to be 8. And if the whole bottom is 18, and this much is 8, then the remainder of this is going to be 10. Okay. Now what I'm going to do is I'm going to draw a little radius on the small circle, meets at 90. This is going to be a radius. This one comes down here is also going to be a radius. And now what I like to do is I'm going to draw a segment to connect the center of the two circles, and then another segment parallel to the rectangle side right here. Okay, now what I'm going to do is I'm going to get dimensions for each side of this right triangle right in here. And then I'm going to use the Pythagorean Theorem. Okay, so we know that this is 8 as the radius of the blue circle, and this bottom part is r, and that's r, which makes this portion here 8 minus r. We know that from this point here to the end is 10, but this little part is r, so that makes this 10 minus r. And we also know that this is the radius of the blue circle, which is 8, and this is the radius of the yellow circle, which is r, so that makes the hypotenuse here 8 plus r, or r plus 8. Okay, I cleaned it up a little bit, and now what we're going to do is we're going to write the Pythagorean Theorem using the three sides of the right triangle. 8 minus r squared plus 10 minus r squared equals r plus 8 squared. I'm going to fool everything out and combine some like terms. 64 minus 16r plus r squared plus 100 minus 20r plus r squared equals r squared plus 16r plus 64. I have an r squared on the right, I have an r squared on the left. We can cancel those out. I have a 64 on the right, 64 on the left. We can cancel those out. Then what I'm going to do is I'm going to move positive 16r over to the right-hand side, combine like terms, and put them in the right order. So this ends up being r squared minus 52r plus 100 equals 0. We're going to factor this, r minus 2, r minus 50 equals 0. So my radius can be 2 or my radius can be 50. Now we know that the radius can't be 50 because of the dimensions of this rectangle up here. So this is an extraneous solution. So we know that the radius has to be 2. So the radius of the small circle is 2, which makes the area of the small circle pi times 2 squared, which is going to be 4 pi. Combined area of both circles is going to be 64 pi plus the 4 pi. So my combined area is going to be 68 pi. And then what I'm going to do is I'm going to do the area of the rectangle minus the area of the circles. So it's going to be 288 minus 64 pi units squared. That's a pretty cool problem. If you enjoyed this video and would like to see more, please smash the like button and subscribe to my channel. I will see you on the next video.